Alright, so we're going to talk about linear equations. A linear equation is basically just an equation that always has two variables. In this case we have x's and y's that we're using here, but we don't have to use x's and y's. We can use q's and w's and b's and d's and whatever, two letters we want, to represent two varying quantities that when you substitute numbers in for them, you end up with a line on a graph. So for example, y equals x is our most basic linear equation, and it's one that we like to compare all linear equations to because y equals x creates a graph that looks just like this. It's a line that goes on forever in both directions that splits quadrant, this is considered quadrant 1, and this is quadrant 3. It splits these two quadrants exactly in half. Okay? It's a diagonal line that crosses through quadrant 1 and 3. Now, these linear equations written here are three different types. They're all linear equations. They all express the same kind of thing. They all help you form a line on a graph. But they're just written in three different ways. The first way is called slope-intercept form. And it always starts off with y equals. Slope-intercept form has a number that's being multiplied to x and then a number being added to x. And it's called slope-intercept form because this tells us the slope, the number that's multiplied to x, and the number being added to x tells us the y-intercept. It just happens to be written in a way where we can readily see those two things. Standard form just means you line up all your variables in order on the left side and then say what they equal. So our x's go first plus our y's, and then it equals a particular number, and that goes on the right side of the equation. And that's just a standard way to write an equation. Okay, and then we have point-slope form. And point-slope form, it just happens to be written, it's still a linear equation, it still expresses a line on the graph, but it's written in a way where you can readily see a point that's on the line and the slope. In this case, this is the slope. And this number tell us the coordinates to a point on the line. It's not as easily used because it seems to be written in a way that confuses students when they're trying to figure out what you do with this equation. But what I like to do is start off with talking about slope-intercept form. And we're going to work with a few examples of this way of writing a linear equation. And just to be clear that we understand, this equation can be written in standard form and in point-slope form. This equation, already written in standard form, can be rewritten so that it's in slope-intercept form or point-slope form, and so on. In other words, any linear equation can just be rewritten. In other words, you balance the equation and move things from side to side in a balanced way, and you can always end up with the same equation that equals the same line on the graph, but just written in a different form so that you can readily see different pieces of information. So we're going to take the slope-intercept form of an equation, bring it down here. So we're going to use the same example. And basically when we say that this number tells us the slope and this number tells us the y-intercept on the graph, move it up. What that means is the 5 telling us the y-intercept, that tells us that our line that we're going to have on the graph is going to cross through the y-axis at the point 5, positive 5. So this is when I draw my units or mark my units up on the y-axis, there's the positive 5. And through that point, my line is going to cross. Now, I don't know yet whether it's going to, I'll do some pencil, whether it's going to cross this way or this way, but somewhere, oh, you couldn't see that, just barely see that in the video. They're in pencil. It might cross what we call a negative slope or cross through at a positive slope. It could be any variation of a very steep positive slope or a very, very shallow positive slope, and so on. But regardless of where this line is crossing through, it's going to cross through at the point 5 on the y-axis. So knowing that, I'll put a little point there. And then the number that's being multiplied to x tells me the slope. So basically, that will tell me to which angle this line is going to go through, or to what slope. This line's going to go through this particular point. Now, it's a lot easier to know slope intuitively than it is to be thinking about slope constantly as rise over run. So all the books tell us when we learn about slope, they tell us that, oh, slope is the same thing as rise over run, or m is the same thing as rise over run. Sometimes they put m in the place of the number here next to the x, and they say, well, that's just rise over run. Yes, that's important to know, and we'll discuss that in another video, but if you just know slope intuitively first, it's a lot easier to figure out what this rise over run means. So when we take this calculator, this is where I like to use a calculator. Hopefully we can see. Yep, we can, the graph. We're just going to take different versions of equations and do y equals 2x. And I'm not going to put plus 5. I'm not going to put that it's going through a different coordinate on the y-axis other than just 0. I want them, if I don't add anything to this, I'm just going to have this line go through the origin, which is 0 on the y-axis. So when I graph that, of course, the graph won't come up. This is a typical problem we have in class. The window gets reset, and then we try to graph something and it doesn't go through. There we go. All right, so y equals 2x. It's not quite the same thing. I'm going to go ahead and put y equals x on here because I talked about that one already, and we're going to compare the two. Okay, the line that just went through the second line that went through the graph is y equals x, and the first line is, which is this taller one here, or the steeper one, is y equals 2x. Do you see how when you multiply a number to x and that number you're multiplying is getting bigger? Let's watch what happens to that number. So instead of having 2x, let's do 3 times x and see what happens. A new line was drawn and it's now getting steeper. And if I do y equals, let's take a big number, let's do 10x. Let's see how much steeper it gets. Now you see it's getting very close to the y-axis. And what's happening is it's getting closer to being a vertical, straight up and down line. It's never going to be there because our number system goes on forever. And so any big number you come up with, there's always a bigger number, which means that line can always get closer to the vertical axis but never quite get there. So let's erase all these. So I know now that 2 as my slope for this particular line gets me a line that sloped not quite like this, but a little bit steeper. It'd be something like that. So, oops, can you see that? It'd be something like the steepness of maybe that line. So I'm going to try and replicate that and bring it over here, and I'm going to say it's something like this. I don't know quite where it's hitting the x-axis, but I do know it's hitting through the y-axis at 5, and I do know the steepness is about like that. And if I just know, and I also know this is the correct direction of the slope because this is over here a positive 2, and this is a positive slope line. Whenever line is going from the bottom on the left and moves upwards towards the right, that means it's a positive slope. Okay. So let's take another example of a linear equation, and this time let's do a negative slope line, but crossing through the exact same point. So basically, I will rewrite that same equation, but make it a negative 2x plus 5. And I'll show you what it looks like on the calculator. Now I'm just going to do negative 2 times x plus 5, and then graph it. I have a line that just came down from the other side in a different direction. This is called a negative slope line. And I can keep changing. I'll do different lines. Let's do negative 3x plus 5. It's still coming down from the top on the left side of the equation, left side of the y-axis, and moving downwards towards the right. Okay, and that's a negative slope line. So my negative slope line is now going to be just like this line, but it's going to be the opposite of that. It's going to be it's going to cross over at the exact same point. 1, 2, 3, 4, 5. So it's going to still cross over here because I still see the same y-intercept. I did that on purpose just to compare to this one. But now I have a negative 2 as a slope. So